Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have you here today, because honestly, we're about to embark on a pretty fascinating journey. Think of this as opening up the ultimate cosmic cookbook. Today, we are going to break down the actual recipe of the universe into its core ingredients. Literally everything you can see, touch, and even breathe is built from a very specific set of rules. And by the end of our time together, you're going to understand exactly how the entire material world is constructed. All right, so here is our roadmap for today's explainer. We'll kick things off with welcome to the material world. Then we'll hit elements, the purest ingredients. After that, we'll look at compounds, the chemical combinations, followed by mixtures, the physical blends. And finally, we'll wrap it all up with mastering the differences. Okay, let's dive right into this. Section 1, welcome to the material world. We're going to start by defining the stuff around us. So we have to start with the big one, the concept of matter. What is it? Well, matter is quite literally everything around us that has mass and occupies space. I want you to think about the milk sitting in your fridge right now, or maybe the wood of the desk you're leaning on, or the gold in a ring on your finger. Heck, even the oxygen you're breathing into your lungs as you listen to this. It all takes up space and it all has mass. Scientists take all this matter and organize it into 3 distinct categories to make sense of it all. Let's look at the very first one. Moving right along to section 2, elements, the simplest form of matter. An element is the simplest pure substance out there, containing only one kind of atom. And I really want to emphasize that word pure. This is a hard, unbreakable scientific rule, guys. You cannot break an element down into a simpler substance using ordinary chemical reactions. They are the absolute rock-bottom building blocks of reality. Now, what's really interesting about this is how you can visualize it. Just imagine you've got a plain cardboard box, and inside that box are hundreds of red bouncy balls. Every single ball is exactly the same size, the same weight, the exact same shade of red. If you reach in and pull one out, it's totally identical to any other ball in that box. That is exactly what an element is. It's a sample of matter where every single particle, every single atom is a perfect twin. Because elements are made of only one kind of atom, they have incredibly reliable fixed physical and chemical properties. We actually group them into different types based on these traits. You've got your shiny, conductive metals, your dull, brittle nonmetals, the metalloids that kind of sit somewhere in between, and the noble gases, which are just so stable they barely interact with anything at all. And they exist in all 3 physical states, too. We have solids, like a heavy iron rod, liquids, like the mercury in an old-school thermometer, and gases, like the helium that floats a party balloon. Actually, before we move on, I've just got to share this incredibly cool piece of scientific history with you. While most elements we interact with occur completely naturally, humanity has actually learned to create some on our own. Take technetium, for example. This was the very first element successfully produced artificially by scientists in a laboratory. We literally played the architects of matter to forge a brand new, pure element. I mean, how amazing is that? All right, stepping it up a level of complexity to section 3, compounds. This is when our ingredients bond permanently. So a compound is a pure substance formed when 2 or more different elements combine chemically in a fixed ratio. Really focus on that phrase for a second. Combine chemically in a fixed ratio. This isn't just a casual hangout. This is a permanent chemical marriage. The ratio has to be perfectly exact every single time for the real magic of chemistry to happen. And this brilliantly illustrates what I mean. Think back to our box of identical red balls. Now imagine a blue ball comes along and essentially glues itself permanently to 2 of those red balls. They form a completely new, inseparable 3-part object. This is exactly what happens with water, by the way. You take one oxygen atom, the blue ball, and bond it to 2 hydrogen atoms, the 2 red balls, H2O. They aren't separate elements anymore. They become a completely new compound. Now, while compounds always have a fixed composition and can be organic, meaning they contain carbon, or inorganic, the absolute most crucial takeaway here is that entirely new properties are formed. When elements combine chemically, they don't just, blend their traits together. They transform into something utterly different. And those original elements, they can only be forced apart again through intense chemical methods. Okay, get ready for my absolute favorite plot twist in all of chemistry. Let's take sodium. Sodium is a highly reactive metal. If you drop it in water, it practically explodes. Now, let's take chlorine. Chlorine is a toxic, highly poisonous gas. So, what happens when you combine an explosive metal and a deadly gas?
Well, they lock together chemically and they become sodium chloride, which is literally the perfectly safe, delicious table salt you sprinkle on your French fries. I know, right? That is the incredible power of a compound. The intense chemical bond completely erases the old dangerous properties and creates a brand new, totally safe substance.
Which brings us to section 4, mixtures. This is all about sharing space, not bonds. We're stepping away from those intense chemical reactions now. So the crucial point here is that a mixture happens when two or more substances are mixed physically, in any proportion with absolutely zero chemical bonding. There is no chemical reaction happening here at all. The substances are just happily hanging out in the exact same space, completely minding their own business. Let's head into the kitchen to really picture this one. Imagine pouring raw rice, dry lentils, and some beans into a big glass bowl and stirring it all up. You have clearly mixed them together, right? But the rice is still rice. The beans are still beans. They haven't chemically bonded into some weird mutant rice-bean hybrid. They each keep their own identity. And because they aren't chemically bonded, you could easily sit there and pick the beans out one by one using just physical methods. Now, mixtures basically come in two distinct flavors. First, we have homogeneous mixtures. Homo just means same. These have a completely uniform composition. Every single part looks exactly the same, like the air we breathe or a glass of water with sugar completely dissolved into it. You literally can't see the different parts. On the flip side, we have heterogeneous mixtures. Hetero means different. These are non-uniform. Think of a scoop of soil from your garden, a rock, or what happens when you pour olive oil into water. The parts remain visibly separate from one another. Let's move on and see how this all builds together in section 5, mastering the differences. I like to call this the ultimate matter matrix. Listen, if you're taking a chemistry class right now, you might want to mentally bookmark this, because this matrix is your ultimate cheat sheet to confidently solve pretty much any textbook or exam question. Just look at how it lays everything out side by side. Elements have one type of atom and absolutely no bonds. Compounds have two or more elements locked in chemical bonds, creating entirely new properties, and you need chemistry to break them apart. Mixtures, they're two or more substances with no chemical bonds. They retain their original properties, and you can separate them with simple physical methods. It really all boils down to this table. To make sure you never forget this, I've got a secret weapon for you, the ECM memory trick. Just remember ECM. E stands for equal atoms. Elements are just equal, identical atoms, one type only. C stands for chemically combined. Compounds are elements chemically fused together in a fixed ratio to make something completely new. And M stands for mixed physically. Mixtures are just things hanging out together, physically mixed with zero reaction, happily keeping their original identity. ECM, if you remember that, you have officially mastered the foundations of matter. So, as we wrap up this explainer, I've got a challenge for you. I want you to become a detective of matter in your own home. Seriously, look around your room right now. Can you identify one pure element? Maybe there's a copper wire somewhere or an iron nail. Can you find one chemical compound, a glass of water on your desk, or maybe some salts in the kitchen? And can you spot a physical mixture? Maybe it's a bowl of trail mix, or honestly, even just the air circulating from your fan. The chemistry of the universe isn't just trapped in some boring textbook. It is quite literally everything around you. Keep your eyes open and keep exploring. Thanks so much for learning with me today.